Have you ever tried to cook and accidentally touched the pan which felt very hot? Or how about opening the freezer in a hot summer day as it fills you with soothing and cooling breeze? Well, this process is what we call heat transfer, which by its term can be pretty much determined on what it does. It transfers heat. Wow, that's pretty much the definition of it, right? Or is it? Heat transfer is a fundamental concept that plays a crucial role in many aspects of our daily lives, from cooking and heating our homes to transportation and electronics. Understanding the principles of heat transfer is essential for engineers, scientists, and anyone interested in understanding how energy is transferred between objects and systems. Now, if you're watching this, there's a high chance that you're probably aiming to be an engineer or a scientist, or maybe something else. Regardless, why don't we take it being essential and dive deeper into the science of heat transfer? So, what is heat transfer? Well, in basic terms, heat transfers the movement of thermal energy from one object or system to another due to a temperature difference. Heat transfer occurs when there is a temperature gradient between two objects or systems, and the energy moves from the object or system with a higher temperature to the one with a lower temperature. Okay, maybe a little bit more basic terms. Heat transfers the way that heat moves from something hot to something cooler. It happens all around us when we feel warmth from the sun, touch a hot stove, or even feel the warmth from another person's body. To further emphasize on this, let's dive deeper again on heat transfer. There are three main types of heat transfer: conduction, convection, and radiation. Conduction occurs when heat flows through a solid material, such as when you touch a hot pot on the stove and feel the heat moving from the pot to your hand. Convection occurs when heat is transferred by the movement of fluid or gases, such as when hot air rises and cooler air moves in to replace it. Radiation occurs when energy is transferred by electromagnetic waves, such as when you feel the heat from the sun on your skin. Okay, I feel like it's a little too much if you tackle each of this, so since I like a sweet hot cup of coffee, well, not too hot, so I blow air into them. So let's take the boiling water of making coffee and blowing air into it into play and see how it works. What I mean is convection. I'm choosing convection because I like coffee. Convection is the transfer of heat through a fluid such as a gas or a liquid due to the movement of that fluid caused by differences in temperature and density within the fluid, which in turn create buoyancy forces. One of the main concepts behind convection is the idea of thermal gradients or thermal differences. When a fluid is heated from below, for example, the lower portion of the fluid becomes warmer and less dense than the upper portion, creating a buoyancy force that causes the fluid to rise. As temperature rises, it cools down and becomes denser, eventually sinking back down to the bottom, completing the convection cycle. Another key concept is the role of viscosity in convection. Viscosity is a measure of a fluid's resistance to flow, and in general, more viscous fluids will exhibit less convection than less viscous fluids. This is because the buoyancy forces that drive convection must overcome the resistance of the fluids to flow. There are several theories that have been developed to explain the details of convection, including the Rayleigh-Benard convection theory, which describes the formation of convection cells in a fluid layer that is heated from below. This theory predicts the size and shape of the cells as well as the flow patterns within them. Other theories include the Taylor-Proudman theorem, which describes the rotation of fluid in a cylindrical container, and the Grashof number, which is a dimensionless parameter that characterizes the relative importance of buoyancy forces and viscous forces in convection. Well, that was a mouthful, and also mindful, but let's provide some examples just to have a clearer view of what convection actually is. From the beloved coffee that I mentioned moments ago, boiling water. When you heat a pot of water on a stove, the heat causes the water at the bottom of the pot to become warmer and less dense than the cooler water above it. This causes the warm water to rise and the cooler water to sink, creating a convection current that heats the entire pot of water. All those boiling really convected the place, huh? Okay, well, for a hot room, a cooling fan would be the perfect device to install. When you use a fan to cool off, the moving air helps to increase the rate of heat transfer from your body to the surrounding air by convection. The air moves across your skin, carrying away heat from your body and replacing it with cooler air. How about diving a bit deeper on the topic, or better yet, in the Earth's mantle? Convection is also responsible for the movement of material in the Earth's mantle, which helps to drive plate tectonics and other geological processes. Okay, that's probably enough examples for you to understand. Diving out of the Earth's mantle and further into outer space, we can find numerous aerospace systems. If it's in the outer space, probably astronautical type of aerospace systems, which include all types of vehicles that operate outside the Earth's atmosphere, such as spacecraft, satellite, and space probes. Speaking of aerospace systems, there are also 4 more other types. Might as well learn about that. Aeronautical systems includes all types of aircraft that operate within the Earth's atmosphere. Avionic systems are electronic systems used in aircraft to perform various functions such as navigation, communication, and control. Propulsion systems are used to generate thrust or propulsion to enable an aerospace system to move through the air or space. Control systems are used to control the movement and orientation of an aerospace system. And lastly, support systems include all the ground-based facilities and equipment required to operate and maintain aerospace systems. Whew, well, that was a breather. But wait, we're talking about heat and mass transfer, right? So you might be wondering, why am I talking about aerospace systems? Well, heat and mass transfer actually play a crucial role in the aerospace systems. Heat transfer is important for maintaining the thermal equilibrium of the system. For example, in the engine of an aircraft or rocket, there are high temperature gases that need to be cooled to prevent damage to the engine components. The cooling is achieved through heat transfer mechanisms such as convection, radiation, and conduction. Mass transfer is also an essential consideration in aerospace systems, particularly in fluid dynamics and aerodynamics. For instance, in rocket propulsion, mass transfer is crucial to understand the combustion process and to optimize the fuel efficiency. Speaking of rocket propulsion, since we're still in space, let's get rid of the other systems and dive, in this case, we're not diving to Earth anymore, so I guess fly into rocket propulsion. So in rocket propulsion, convection occurs in combustion chamber and the exhaust nozzle. The combustion process takes place in the combustion chamber, where fuel and oxidizer are mixed and ignited to produce hot gases. These hot gases are at high pressure and temperature, and they expand rapidly, causing them to move towards the exhaust nozzle. As the hot gases move toward the nozzle, they transfer heat to the nozzle walls through convection. The nozzle is typically designed to withstand the high temperatures and pressures of the excess gases, and it may include cooling channels or other features to help dissipate heat. In the exhaust nozzle, the hot gases expand further and accelerate creating thrust. Well, was all of that headache? Don't let it get to you so much, and try to understand it little by little. But basically, heat and mass transfer are critical in aerospace systems, as understanding it is important for developing new materials and technologies that can withstand the extreme conditions encountered in aerospace environments. Even in our everyday life, heat and mass transfer are involved in many other everyday processes and technologies such as refrigeration, air conditioning, cooking, and drying. Understanding these processes can help us make better use of these technologies and can also inform the development of new materials and technologies that can improve our daily lives. So you can always try to understand it. Now grab yourself a hot coffee and be sure to apply convection to it. Blowing, and enjoy the rest of your day.